Today we'll see about electrical energy, how we are calculating electrical energy, and also we'll see what is electrical power. Okay, so in our daily life, we used to see a lot of things that work on electricity. So you could see that if you are taking the case of an electric fan, so that fan is actually using electricity, and that electricity or electrical energy is converted to mechanical energy, isn't it? Now if you are taking the case of an electric iron, there the electrical energy is converted to heat energy. Then if you are taking the case of many other things that works under electricity, like washing machine or maybe microwave, or maybe any other thing, geyser, or even the speaker, where electricity is used, electrical energy is actually converted to some other forms of energy, isn't it? So electricity actually is a form of energy, and that electricity can be converted to other forms of energy. And also we can produce electricity or electrical energy from different other forms of energy. That is, usually electricity is produced from the mechanical energy of the flowing water, isn't it? Hydroelectric power stations. Then it is also produced from the thermal energy in thermal electrical power station. So electrical energy is actually it can be converted to other forms of energy, and electrical energy can be produced from different other forms of energy. So we will see here how electrical energy is measured, and what is the equation for electrical energy in terms of current and the potential difference, which we have learned in the earlier classes. Let us see how to measure electrical energy. So energy is actually work done, isn't it? Work done is converted into energy. Now when we learned about potential difference, we learned that potential difference, or V, is equal to work done per unit charge, isn't it? From the definition of potential difference or potential, we learned that it is the work done to move a charge from infinity to a particular point, isn't it? So that is work done per unit charge. So from here you can find the equation for work as W is equal to charge Q multiplied with V, that much joule, isn't it? So here work is actually, the work done is the energy which is being stored. So you can write energy or electrical energy as the potential difference or the potential V multiplied with charge. Okay, so that is electrical energy in terms of charge and potential. But usually when we consider electricity, we don't have any particular measuring device for measuring the charge and all. We usually represent electricity in terms of current, isn't it? Now we are going to convert this charge in terms of current. So for that, charge is equal to current multiplied with time. Or to understand better, we'll take the definition of electric current. Okay, we have learned that electric current is equal to charge, rate of flow of charge, that is charge upon time, isn't it? So from this equation, electric charge Q is equal to, current is represented using the letter I, so electric charge Q is equal to current I multiplied with T, time, isn't it? So we got the equation for charge in terms of current and time. So you can put that equation in the equation for energy. So electrical energy can be written as voltage multiplied with current multiplied with T. Or you can write electrical energy is equal to, just for VI Okay, VIT. So electrical energy in terms of current, voltage and time is VIT. That is, suppose I amount of or I ampere of current is flowing through a conductor for so let us suppose that this is a conductor and I ampere of current is flowing through that conductor, and let it be flowing for t seconds. Okay, and let us suppose that we are giving a potential of V voltage, that is voltage or the battery which we have used is of potential V. Then we can say that the energy which has been produced here in the conductor is equal to voltage multiplied with current which is flowing multiplied with the time of flow of the current. Okay, so that is electrical energy. Now we can you know the unit of energy. Energy unit is joule. Okay, so you can even define joule in terms of voltage, current and time. So 1 joule will be 1 volt multiplied with 1 ampere multiplied with 1 second. That is, suppose a conductor is carrying a current of 1 ampere for 1 second, and if the potential which we apply for the conductor or between the conductor is 1 volt, then we can say that 1 joule of energy is there for that conductor, or 1 joule of energy will be across the conductor. Okay, so 1 joule of energy will be there for the electrical current if 1 ampere of current is flowing through a conductor for 1 second when we are applying a voltage of 1 volt. So that is the expression for electrical energy in terms of voltage and current. Now we can have more expressions from Ohm's law. So from Ohm's law we have learned V is equal to I multiplied with R, where R is the resistance of the conductor. Okay, so in terms of resistance also we can modify the equation for electrical energy. So you have electrical energy is equal to VIT, that is what we have learned earlier. So that is one equation. Then instead of V I can put IR, that is current in multiplied with resistance. So energy can have another equation, IR multiplied with I into T, or it is I squared RT. Okay, so this is the second equation for electrical energy, I squared RT, that is in terms of current and resistance of the device. Now similarly, electrical energy can be written in terms of voltage and resistance. That is, we have energy, basic equation is energy is equal to VIT. Okay, and instead of current I can write V by R. So the equation can be modified as V multiplied with, instead of I, what should I write? V by R multiplied with T. So we got yet another equation, that is V squared by R multiplied with T, which is the third equation. Okay, so we have different equations for electrical energy in terms of voltage, current, charge, resistance, etc. So we will conclude that, or we will write all the equations together. So electrical energy, we'll write electrical energy itself. Electrical energy can be written as, it is Q multiplied with V, where Q is the charge and V is the potential. Then it can also be written as VIT, where V is the potential difference, I is the current and T is the time. Everything should be written in SI unit. Then it can also be written as I squared RT, where I is the current, R is the resistance and T is the time. Also it can be written as V squared by R multiplied with T, where V is the potential difference, R is the resistance. So here Q is the charge, then V is the potential, or we can even write it as voltage. Okay, and charge will be in coulomb, V will be in volt. We have learned it earlier in the earlier classes. Then I is the current, then R is the resistance, and T is the time. So if all these quantities are taken in SI unit, the unit of electrical energy will be in joule. So SI unit of electrical energy is joule. So we found about the expressions for electrical energy. Now we'll see what is electrical power. So in mechanics we have learned about power, and we have learned that power is rate of doing work, isn't it? Power, we can define it as, it is rate of doing work. So rate of doing work means, if you convert that into equation form, it is work done by time. Okay, or you can write power, let power be represented using letter P. Power is equal to work by time. So this work, as I told earlier, it is actually the energy. Now we are doing with electrical power. So it will be electrical energy divided by the time, isn't it? So we can write power, that is electrical power, is equal to electrical energy divided by T. So we have learned the equations for electrical energy, isn't it? So you just have to put the value of that equation, or those value here. So you can write, first one which we have learned is VI T divided by T. Okay, VIT is the energy or electrical energy. There T and T will get cancelled. So we have the first expression as V multiplied with I, where V is the potential or voltage and I is the current. So that is the first expression that you have for electrical power. So the basic expression is power is equal to voltage V multiplied with current I. So this is the basic expression for power. Now using Ohm's law, you know V is equal to IR. So instead of V, I can put IR. So the power can be again rewritten as, instead of V, I will put IR, then multiplied with I. So power is equal to I squared R, which is the second expression. So this is the first expression, second expression. Okay, now the third expression you can write is power is equal to V squared divided by R. That is the third expression. Actually we had three expressions for energy. The first one was VIT, then second one was I squared RT, and third one was V squared by R multiplied with T. So there in all the cases the time will get cancelled. That is, you know, an energy upon time is the power. Okay, so all the time factors will get cancelled and the power equation can be written as P is equal to VI, or power is equal to I squared R, or power is equal to V squared by R. So we'll just conclude power, electrical power, is equal to electrical energy divided by time. So if you are writing it in letters, P is equal to W by T. Also, you just write the value of W. W can be have three values, that is, it can be VIT, it can be I squared RT, or it can be V squared by R multiplied with T. So if you put those values of W, the time factor will get cancelled, and we have these expressions as power. Power is voltage multiplied with current, or it can be I squared R, where R is the resistance, or it can be V squared by R. So these three expressions can be used for getting the power, electrical power. Now, as we have learned in mechanics, the unit of power is watt. Okay, so if I am writing the definition of watt, I can write 1 watt is equal to, if I am using this equation, 1 volt multiplied with 1 ampere. That is, suppose I have a conductor, and if I am giving 1 voltage battery, 1 volt battery, and if a current of 1 ampere is flowing through that conductor, then the power developed there will be 1 watt. Okay, so the power of a device, okay, so let this resistance be a device. So the power developed, or power of that device, will be 1 watt if 1 ampere of current is flowing through that conductor or resistance. If I am giving 1 volt power supply, that is, if the battery potential is 1 volt, and if 1 ampere of current is flowing through the conductor or resistor, then the power developed there will be 1 watt. Okay, so that is about the electrical power. For electrical power, even though SI unit is watt, we have other units also to represent power. One of the higher unit is megawatt, 1 megawatt. So 1 megawatt is actually 10 raised to 6 watt. Also 1 kilowatt. Kilo means 10 raised to 3 watt. Yet another unit of power is there, which is known as horsepower. Horsepower. So the same we have learned in mechanics also. Same only we are using in electrical energy or electrical power. So 1 HP or 1 horsepower is 746 watt. So these are the things which we have to learn about electrical energy and electrical power. Now in next classes we'll see how to find out the commercial unit of electrical energy, how to do the billing of electrical energy, that is how to find the value or amount which we have to pay as electricity bill. Then we also will see certain important things related to devices, like power rating of devices, that is how you can calculate the current, maximum safe current which can be flown through a device, okay, using power rating techniques and all. Okay, so that we'll see in the coming videos.